the first approach is already discussed, now let's move in the next approach that is being suggested by FOPAM, which is the empirical-based procedures. Empirical-based procedure is a test developers refer to this technical process as an item analysis as it utilizes data obtained separately for each item. So an item is considered good when its quality indices, so example, the difficulty index and discrimination index, meet certain characteristics. So in this approach, we will going to solve the discrimination index and difficulty index. We will also encounter such formulas to be used in order to recognize what kind of index does your students or their performance belong. For a norm reference test, these two indices are related since the level of difficulty of an item contributes to its discriminability. In norm reference test, the reason why its level of difficulty is discriminability because students are actually competing to achieve a standard performance that will classify them into the desired score. Just like, for example, if a student get high score, of course, she or he will be classified as an excellent or good student. So for the context of criterion reference interpretation or testing for mastery, an item with a high difficulty index will not be considered as an easy item and therefore a weak item, but rather an item that displays the capability of the learners to perform the expected outcome. It therefore becomes evidence of mastery. In empirically based procedures, there are difficulty index, discriminating index, distractor analysis, and sensitivity to instruction index. But we will just focus on difficulty and discriminating index. Difficulty index, an item difficulty index is obtained by calculating the p-value, which is the proportion of students answering the item correctly. So we'll just solve for its p-value. So P is equal to R over T. So where P is the difficulty index, R is equal to total number of students answering the item, and the T is equal to total number of students answering the item. So for item number 1, there were 45 students in the class who responded to item 1 and 30 answered it correctly. So we will use the formula, which is P is equal to RT. So P is equal to 30 over 45. So the result is 0.67. So in item 1 has p-value of 0.67. 67% got the item right, while 33% missed it. So in the item number 2, in the same class only, 10 responded correctly in item 2. So we will use again the formula P is equal to RT, R over T. So P is equal to 10 over 45. So the result is 0.22. Item 2 has a p-values of 0.22 out of 45. Only 10 or 22% get the item right, while 35 or 78% missed it. So for normative reference tests between the two items, the item 2 appears to be a much more difficult item, since less than a fourth of the class was able to respond correctly. For the criterion reference test, the class shows much better performance in item 1 than item 2. It is still a long way for many to master item 2. So discrimination index is the power of an item to discriminate between informed and uniform groups, or between more knowledgeable and less knowledgeable learners, is shown using the item discriminatory index, which is represented by D. For the classroom test, the discrimination index shows if a difference exists between the performance of those who scored high and those who scored low in an item. Discrimination of the result. Positively discriminating item is the proportion of the high scoring group is greater than of the low scoring group. So yung mas marami pa yung nakakuha ng high score kaysa sa low score. So the negative discriminating item is the proportion of the high scoring is less than that of the low scoring. So di bale opposite sila. Sa negative is yung mababa lang yung nakakuha ng high score. And then, the third one is not discriminating. The proportion of high scoring is equal to that of the low scoring group. So, equal lang yung nakakuha ng high score and then sa low score. So, di bali pantay lang sila. These are the formulas to be used. So, we have the first formula is that D is equal to RU over TU minus RI over TI. And the second formula is we have D is equal RU minus RI over T. And the third one is D is equal PU minus TI. Where D is item discrimination index. The RU, number of upper group getting the item correct. The TU, number of upper group. Then the RI, number of lower group getting the item correct. The TI, number of lower group. And the T, number of either group. The PU is the p-value for upper group, which is PU over TU. And then the PI is the p-value for lower group, PI over PI. To obtain the proportion of the upper and lower groups responding to the item correctly, the teacher should follow this step. So letter A, score the test paper using K to correction to obtain the total scores of the students. Maximum score is the total number of objective items. Letter B, order the test paper from highest to lowest score. C, split the test paper into halves, high group and low group. For a class of 50 or less students, do 50-50 split. Take the higher half of the high group and the lower half as the low group. For a big group of 100 or so, take the upper 25 to 27% and then lower 25 to 27%. Maintain equal numbers test papers for upper and lower group. D. Obtain the p-value for the upper group and p-value for the lower group. So we have the formula here. The P for upper is equal to RU over TU. And for the lower, P is equal to RI over TI. Letter E, get the discrimination index by getting the difference between the p values. That's all. Thank you.